Hi guys, Mr. Sonnenberg here. Today we're going to be talking about the wave model of light. This is for Science 8 students studying light and optical systems, and this is topic 7 in your textbook. So the first thing we need to do is we need to take a look at what a wavelength is. So light, when we look at it, doesn't appear to travel in straight lines, because sometimes we can see how light is refracted and we can see the different directions light moves. But when it actually passes through a small opening, it's going to spread out around each side of that opening. So as it passes through, it spreads out. And so light doesn't travel in straight stream of particles. It actually travels in waves. So instead of having it straight, we're going to talk about this wave model where light travels as such. Okay, so there's features of the wave. So if I was to draw a wave here, and just think of a wave in the water, same thing applies. Okay, here's the wave in the water. Well, the high point up top is going to be called the crest. Oops, that's supposed to be an arrow. That's the crest. Now the low point down here at the base is called the trough. Okay, so now what happens is, if I was to put an object in here, the object is just going to move vertically. It's going to rise and fall with the wave, but it's not going to move horizontally. So in this next picture, when I talk about the crest and the trough, if you take a look here in this image, you can see the crest again up top, see the trough below, they're labeled. We have a duck. Now what's going to happen with the duck is it's just going to move in the vertical position here like such. Okay, it's not moving side to side. If you just look at the position of the duck right now, if I was just to draw a line, okay, straight through the duck all the way down, okay, then you can see that it's in the same vertical position or same position, so it's not moving side to side or horizontally. Okay, so what happens is that duck is just going to move up and down with the wave, but remember, the high point is the crest, the low point is the trough. Alright, so if I was in a kayak and I was floating, okay, same concept, or in a boat or such, and then I'm not moving horizontally, I'm just moving up with the wave, down to the trough, so up when I wave crests, down to the trough, and just move past that resting position. Okay. So the distance we talk from trough to trough, so at the base, is what we call the wavelength, or from crest to crest. So if you just take a look right here, okay, so here's the crest, the high point right here. Here's another crest here as well. So the point between those two, okay, those 2 points is what we call the wavelength. Same thing occurs if we go from trough to trough. So we have one here, one trough here, and that is the wavelength. So we can measure these wavelengths moving from trough to trough. So if the wind was to start blowing, the water was to become rough, okay, what we would see is we'd see higher crests and deeper troughs, okay, would form. So now what happens is that height between what we call the rest position, okay, and I'll just outline that with red right now. The rest position is this dotted line all the way across the screen. So I have my crest up top, which is my high point, my trough, which is my low point. Now what's going to happen is the depth between from the crest to the resting position is what we call the amplitude. Okay, and so you'll see that right here with this arrow. Okay, it's actually showing the distance from the resting line to the crest, and that distance up top there is what we call amplitude. Same thing if we're to go from that rest position. So if the water is completely flat, or this wave was completely flat, from that point down to the deepest part of the trough, that's what we're going to call the amplitude. Okay. Excuse me. So the rate at which the duck moves up and down is what we call the frequency. So that's basically the number of cycles by a vibrating object in a unit of time. So frequency is normally measured in hertz or cycles per second. So if I was to say something vibrates 20 times in a second, I would say its frequency is going to be 20 hertz. So light behaves just as the model states. It behaves like waves. Okay, so as it passes through a small opening, the waves spread out. Okay, and basically how far those waves spread out, though, that depends on the wavelength of that wave. Now remember, the wavelength, okay, is the distance between crest to crest or trough to trough. So depending on that wavelength, that's going to determine how far these waves will spread out. So if I have short wavelengths, then the waves will spread out very little. If I have long wavelengths, then it's going to spread a lot more. Now there's different colors in the spectrum, and we'll be talking about this spectrum as well, but there's different colors in the spectrum and they all have different wavelengths. And so because of that, they're going to behave differently due to those wavelengths. Now if certain lights spread out more or less based on their wavelength size, then there's going to be varying reactions and such. So anyways, guys, that is the wave model of light. I hope this has helped. I hope you take down some notes. You can reference this in your textbook as well in topic 7. And hopefully this has helped. Okay, thanks for tuning in. Bye.